Alright, so this video is about what happens when our forces in our force diagrams no longer balance and cancel. So if you remember our last unit, we had all of our forces where they actually balanced. And so we were under a couple things that we could do, stipulations that we could use to help us solve for different components of a force diagram. We knew that if the forces were balanced by looking at the velocity being constant or zero, or knowing the acceleration is zero, then we could take that and know all of the forces are going to add up, or the sum of all of the forces will be zero, meaning that our x forces will all cancel, our y forces will all cancel. The way that we talked about that most is when we would put it into rights and lefts, ups and downs. So all of this is basically saying the forces to the right will equal to the forces to the left, the forces to upward will equal to the forces downward. Now, that was previously when our forces balanced or when there was no acceleration. Okay, we have a new set of rules to add on, okay, from Newton's second law. So Newton's second law basically states this, that the unbalanced force an object occurs is equal to the mass of that object times the acceleration. Now, Newton originally actually wrote this as acceleration is equal to force over mass, saying that the acceleration an object experiences is proportional to the force or inversely proportional to the mass. And we actually learned that, we looked at that when we were studying our lab with an object on a string. So if you remember, when we looked at this, the unbalanced force caused the whole system to accelerate. And so we found from this lab that the force we applied was proportional to the acceleration. As you increase force, that was the second half of the lab, the acceleration increases. As you add mass, it's inversely proportional to the acceleration, meaning that as you add mass, acceleration decreases. Now, for our purposes, though, this is what we use to be able to calculate acceleration or unbalanced force when things don't balance. So, we will have an unbalanced force. Now, you'll probably see it in textbooks as F is equal to ma. We put the U there kind of to help you remember, but also to be able to know, like, this is the force that's unbalanced. Now, you'll see it sometimes called the net force, or the total force, or the sum of all of the forces. Ultimately, the unbalanced force is all of the same. It means it's what's left over when all of your forces balance, and there's still something there. Okay? Mass, obviously, is the same as it's always been. Got to be in kilograms, because the Newton is derived off of the kilogram, and then acceleration, we always use meters per second squared. So, examples of where this could apply. A homework quiz question that we've given in the past, might be giving to you guys again this semester. But here it is. An applied force of 100 newtons is used to accelerate a 25 kilogram object to the left across a frictional surface. The object encounters 25 newtons of friction. Draw a force diagram to determine the normal force, the weight, the net force, and the acceleration of the object. Now, like always or usual, we're going to neglect air resistance. So, if I were to work through that problem, this is what I was given. Okay, I was given 25 kilogram object on a frictional surface, so there's a friction of 25 and a force applied of 100 newtons to the left. Okay, but I also know, based off of what I know from our last unit, I do have a force of gravity and I do have a force normal. And since it's a flat surface, I can say those two will balance and cancel. Now, 25 kilogram mass times gravity, so 25 times 9.8, that's going to give me my force of gravity, or my weight, one of the things I was asked to solve for. That becomes 245 newtons. And since I know these are equal, I can go right up to my normal force, and I can also say that's 245 newtons. But what I have to figure out is what my unbalanced force is. So my ups equal my downs, but my left does not equal my right. So you can do this a couple ways, but I think the easiest way is to then go back and just remember that the sum of the forces is equal to these added up. Okay? So it'd be our force applied plus our force normal. Now, I say the sum of all the forces, but really what we're finding here is our unbalanced force, okay? And it's my applied force and my normal. Now, since I have these on the same side of an equal sign, I have to show these are opposite direction by saying my 100 Newton force is negative because it's to the left, and my normal force is positive because it's to the right. And so as I go through that, then my unbalanced force, that's going to accelerate the system to 75 newtons, and it's to the left. So you could say it like that, or you could say 75 newtons left. Okay, but the power of this equation that we just got isn't to find the unbalanced force, it's to now relate force to the way something moves. So we know that this object's going to accelerate based off of Newton's second law, and I can solve for what that would be. We just came up with our unbalanced force of 75 newtons. That's going to equal my mass, which is 25, times my acceleration. If I divide both sides by 25, my acceleration will end up being 3 meters per second squared. Okay, so just an example of how we can take information from a force diagram to find an unbalanced force, or to add all the forces up. We can then take it and apply it to something that will tell us how the object accelerates. So that's an introduction to unbalanced forces and how we can apply Newton's second law. See more videos to come.